Hey, welcome back to Mr. P. with Precal. This is Unit 1, Topic 1, SLT8, as we deal with composition of functions, and we're also going to be talking about decomposition of functions. Alright, so warm up. Find f of g of x and g of f of x. State the domain of each. Okay, so f of g of x, we'll start with that first. We're going to take this function and put it in right here, so that's 1 over x minus 1 plus 1. First thing I'm going to do is get rid of that x minus 1 by multiplying everything by x minus 1, and this times x minus 1, and this times x minus 1 basically just cancels out. So I'm left with x minus 1 over 1 plus x minus 1. The 1's cancel out because 1 plus negative 1 is 0, so I'm left with x minus 1 over x. Now, so basically the domain can be all real numbers. The only thing that x cannot be is 0. So f of x, so x can be anything. So x is a set of all real numbers in which x cannot be 0, or neither can x be 1, because if you put 1 in for here, you get 0 as well. 1 minus 1 is 0. So always put into the inner one, has to be equal, can't be 0 equal either. If I do the same thing, I put this function in for this one, so it's 1 over x plus 1 minus 1, and I'm multiplying everything by x plus 1. And then these cancel out, so I'm left with x plus 1 over 1 minus x minus 1. 1 minus 1 makes 0, so this basically cancel out, so I'm left with just negative x. So a domain is a set of all real numbers in which x cannot be negative 1, because if negative 1, so opposite of negative 1, 0, can't be 0. Let me try that again. So it can't be 0 because opposite of 0 will still be 0, and it can't be 0. But it also can't be negative 1 as well. So negative 1 was the right answer because it can't be negative 1 there either. Okay, so random composite function review. So what if we did f of x, and this was f of x? So then we know that we have x squared plus 1 is in the x spot, and all of that is squared and then added to 1. Alright, so we're squaring everything on the inside, so this becomes x to the 4th, and so you multiply its outers would be x squared, and inners would also be x squared, so that's 2x squareds, and the last 1 times 1 is 1, sorry I just did FOIL, and then add 1 at the end, so you get x to the 4th plus 2x squared plus 2, which is e, c is not on here. 2, find the domain of f of g of x. Where f of x is this and g of x is this. Okay, so we're taking g of x and we're plugging it in right there. So that's 1 over square root of x plus 4 minus 2. Okay. Find the domain. So the domain, and keep in mind it's a square root function, which means x can't be anything. It's plus 4. It's always the opposite. So x has to be greater than or equal to negative 4. So that we do know. And there is a hole here. So we need to say that this cannot be 0. So square root of x plus 4 minus 2 cannot be 0 because the denominator is never allowed to be 0. So if I add 2 to both sides, I get square root of x plus 4 equals 2. Square both sides, and you get x plus 4 equals 4. Subtract 4 from both sides, and that tells me that x cannot be 0, in which x cannot be 0. So you have a hole on this. Question number 3, so find f of g of 1. So f of g of 1. So first find g of 1. G of 1 is 2. Well, that's pretty easy. Now I find f of 2. So f of 2 is 0. The answer is 0. F of 2 equals 0. 0 is your answer. Alright, on to the next. So now we're going to be talking about decomposition of functions. So now we're being given find f and g such that h of x is equal to f of g of x. So we're being given h of x, and we're trying to find out what is f of x and what's g of x. We're taking the final answer and we're decomposing it down to. Now keep in mind there could be multiple answers for some of these. We're trying to decompose it into 2 different answers, and I'm sure you can come up with multiple ones. So what would f of x and g of x be? So it's just kind of it's just logical, honestly. So in this case, So I'm going to make, so f, keep in mind that it's f of g of x. So g of x is going into the place of f of x. All right, so if I make f of x, x minus 1, and g of x could be x squared. So if I take x squared and I plug it into the x, then I got x squared minus 1, which is our end result. Like I said, not the only way to do it. So we have f of x here and g of x, and we're looking for something that I can put into f of x to make it g of x. So if I have square root of, let's see, I believe x plus 1, and then I put x square root, no, if I just put x minus 1 here. So if I take this and I plug it in for x, the minus 1 and the plus 1 are going to cancel out, and you're left with just square root of x. 1 over, so f of x and g of x. So I want to take g of x and plug it in for f of x. So this could be, okay, so this could be the easiest one I'm finding is 1 over x, and then make this x minus 1. So if you take this x minus 1, plug it in for x, you get 1 over x minus 1. Last one, I've been stopping for about 10 seconds to give myself some time to think for the other one. So let's see if I can see this one in advance. X plus 2 over 3. Okay, so I'm thinking x over 3 for f of x, and then making g of x x plus 2. If you take that x plus 2, plug it in right here, you get x plus 2 over 3. All right, so to these, they look way more difficult. In the end, actually, I consider these easier. I'm probably not even going to have to pause this one. This looks way more difficult than the last one. However, you're noticing that there's a repetition here. There's a lot of x minus 5s. So you have f of x and you have g of x. It's pretty obvious that I'm going to make the g of x x minus 5. And you're just plugging that in for wherever you're going to have x. So you have negative 3x squared plus 2x plus 7. So basically, wherever I had x plus 5, I just put an x, and I just copied this. So I looked to see what was repeating a lot, and I made that g of x. And then I made all of those places where it was an x. So actually, these look way harder than the last question, but actually I can do these without even pausing. So f of x and g of x. So first of all, I noticed that there's x plus 7, x plus 7, x plus 7. So that's kind of the giveaway. This is going to be x plus 7. And then I just write it as if this is just an x, this is x, and this is x. So that's 2 times sine of x minus x squared plus 3x, and I'm done. All right, and I move on. So now we're getting into, okay, so in this question, you're basically being told that you're getting a 3% commission on any sales that you have over $5,000. You're going to receive $220 weekly, and assume that you're selling enough a week to get the commission. So assuming that, so we have f of x is 0.03x and g of x is x minus 5,000. So we're trying to figure out which one of these two answers represents your commission. Is it f of g of x or g of f of x? So what I've done here is taken this, plugged it in for x, and that's what we have over here. Or g of f of x, take this, plug it in for x over here, and solve over here. Now we've decided to make x $6,000. Actually, you can make whatever you want as long as it's a number that's greater than $5,000. So to show something that would be easy, because 6,000 minus 5,000 is 1,000. Multiply that by 0.03. And you've got yourself $30 worth of commission. That makes sense. Check. So this is looking like the answer. If you do it the other way around, if you take g of f of x as your function and solve, you don't get the right answer, because this percent of 6,000 is going to be a lot less than 5,000. It wouldn't make sense, because that would actually mean that you would owe them money, and that doesn't make sense in the context of the question. Okay, so basically when you read this question, it tells you that your computer screensaver is an expanding circle. It starts in the center and it grows bigger over time. And it also tells you that the entire viewing area of your television is, well, it doesn't really matter how big the television is, because it's going to expand in a circle is a 10-inch radius. And it takes 4 seconds for it to expand. So if you divide 10 divided by 4, you're going to get 2.5 inches per second. So that's how fast it's expanding. And then how much area that it takes up, because the circle reaches the corner in 4 seconds. Express the area of the circle, it says, is pi times radius squared. Discounted off by the edges of the viewing area as a function of time and t amount of seconds. So A of r of t. So if we take this and we plug it in for r, so we get pi times 2.5 times 2.5 t per second. And then we solve it. We square everything on the inside, multiply it by pi, and you get this answer. And this describes the composition function in context that represents the area of the circle in terms of time. All right, so for this question, we have a spherical balloon, which I know that's not normal for a balloon to be a sphere perfectly. But the reason why we made it a sphere is because you learned in geometry that 4/3 pi r cubed is the volume of a sphere. And we know that it's going at a rate of 3 inches per second. So that's the rate at which it's going, and this is the volume. So V of r represents your volume. So V of r of t will represent your volume per time. So it's the volume of the balloon in terms of time, so V of r of t. It's just in the order that it's written, so that's pretty easy to write it in the context of the question. So now it's just a matter of solving it. So we take this and we plug it in right there. And the first thing that you can do is cube what's on the inside. 3 times 3 times 3 is 27. So that's 27t cubed. The next thing to do is divide both of these by 3. So that gets rid of this 3. This becomes a 9. 9 times 4 is 36, so it becomes 36 times pi times t cubed, and that's your answer. All right, thanks again for watching, and that's the end of this composition, and I think, oh no, we didn't do decomposition. So we did composition of real-life examples. Thanks again for watching, and have a great day.